Scientists at the Royal Free Hospital in London have been working on the problem of Factor VIII for 5 years. What they've done, in conjunction with an American genetic engineering company, is to develop a technique for making synthetic Factor VIII, the clotting agent that's missing from haemophiliacs' blood. The technique depends crucially on extracting the human gene for Factor VIII, the hereditary particle that controls production of the clotting agent.
The gene has been genetically engineered into a virus, and the virus has then been used to infect hamster kidney cells, and then, lo and behold, the hamster kidney cells make human Factor VIII. The human Factor VIII, we hope, will be able to be used to treat haemophiliacs and will be a replacement for the present product, which is derived from the blood of donors, from thousands of donors, and carries the very grave risk of transmitting AIDS and hepatitis.
The process starts with extracting very pure Factor VIII from human blood and storing it in liquid nitrogen. That's easier said than done. To make this much Factor VIII requires blood from thousands of donors. Very pure Factor VIII is a protein, a long chain of subunits called amino acids. The Factor VIII prepared at the Royal Free was sent to America, where scientists identified a sequence of 12 unusual amino acids. That sequence matches another unusual group of units in the human gene that controls the production of Factor VIII, allowing the Americans to fish out that one gene from the thousands in every human cell. They then put the gene into a virus, where it multiplied and infected hamster cells with the virus. The gene produced more and more Factor VIII, in effect turning the hamster cell into a Factor VIII factory. For haemophiliacs like Clive Knight, synthetic Factor VIII is a godsend. Knight visits the Royal Free to receive Factor VIII, which he knows could be contaminated by AIDS virus, and the new synthetic form won't be available for perhaps 5 years.
Change that means we can.
For the future, that's a marvellous prospect, because that sounds as though it's going to be the purest product that's been available to us. But until it is available, the situation is still serious. There is a plasma shortage, and that there are the various problems such as AIDS, which have been going on for some time, we've been aware of for a while. So until synthetic Factor VIII is available, the situation is still disturbing for us, I think.
At the moment, Britain makes less than half the Factor VIII the 5,000 British haemophiliacs need to stay alive. It's extracted from human blood. The red blood cells are removed first, and the remaining plasma spun in these steel tubes to leave a white mass containing the Factor VIII. But the rest has to be imported, largely from the United States, where AIDS is much more widespread.
We're beginning to get information that the content or the frequency of AIDS infection from American Factor VIII concentrate is very high indeed. And the evidence is that a high proportion of our patients have been exposed to the AIDS virus.
So why do we have to use American Factor VIII?
The reason goes back in time to the 60s, when many doctors looking after haemophiliacs in this country asked for increased capacity to fractionate Factor VIII, and that capacity was never put in place, and the shortfall had to be taken up by buying in from commercial blood fractionators who operate in the States.
So you're saying that because the health department wouldn't pay for us to make our own Factor VIII, we have to import the American? Correct.
Yes, that's been the case over the last 10 years.
When this new £20 million laboratory being built at Elstree is complete, it will make all the Factor VIII Britain needs. In the meantime, the government has said it will heat-treat Factor VIII to kill the AIDS virus. But doctors treating haemophiliacs are still worried.
The Elstree plant, which is intended to make Britain self-sufficient in Factor VIII concentrate by 1986, will certainly be able to handle the processing. What is in doubt is whether the regional blood centres will be able to collect enough plasma to keep that factory working.
Mr. Clarke, what do you say to criticisms that haemophiliacs are exposed to the risk of AIDS from imported American blood because the government hasn't provided enough funds to make Factor VIII in England?
I find them quite inexplicable because in the middle of all the attempts that we've been making to deal with this very worrying problem, the one thing we haven't done is starve the factory, as we call it at Elstree, of the necessary funds. The whole project to make us self-sufficient in Factor VIII has not at any stage been affected by any reduction in expenditure. Indeed, it keeps costing us rather more than we first expected, and we keep committing the money to it.
But doctors we've spoken to say that when the centre at Elstree is complete, there won't be enough plasma as raw material. Can you give them a guarantee that the regional blood transfusion centres will have enough money to take the plasma that will be needed?
We've been taking that up with the regional health authorities, and we're getting assurances from them that they will be delivering sufficient plasma. I agree it's important. We will need more plasma in order to be able to produce the Factor VIII, but the regional health authorities are telling us they will produce it, and we, of course, will have to make sure they do.
The government said that Factor VIII in Britain will be heat-treated to try and kill the AIDS virus. Why can't that be done sooner than next April?
The board who've run this service have just announced that they think we ought to do that. We're taking expert advice on whether heat treatment will be a proper protection against AIDS or whether some other method will be more effective. Obviously, we're as anxious as everybody else to sort that out, see whether heat treatment's effective, and then have a look at the practicality of doing it.
But surely it's only